Well, good evening and welcome to another exciting episode of Tim Times Projects. Here you're looking at a meteorite display. It's just a bunch of meters. And there's actually a method to my madness, but I have them all hooked up to something. And I just wanted to show you something that the dog brought over. Oh, he's dropping everything. The dog brought this over. It's a lovely toy, and makes the kids happy and everything until, rah! Yeah, my kids thought that was great years ago when they were younger. Anyhow, so there's the bunch of meters that I have here, and we'll start with the Fluke full digital automatic. Everything's automatic. Everything about it nice, easy to use. Then next to it's a Simpson 260, old school meter, but they still actually, I believe they still make them to this day. Same thing, probably a different version. That's I think a version 7 right there. And then is a heat kit, and that's a VTVM vacuum tube voltmeter. These two are vacuum tube. That's a VOM, and that's a digital. The VOM just is volt micro ammeter. But these two are vacuum tube controlled, and I think you remember I did some videos on redoing these. Anyhow, that's the Ico and the heat kit, and then in the background you can see the GW Instech, the benchtop meter, and now that's just, I've had that for forever, and I was just looking at it trying to figure out why the numbers are so far off on that, and it's never been calibrated that I know of. So that might be something to look at later. We may have to do a little calibration on that thing. But what I have here real quick is I guess what the catalyst to all this was, and I'll have to look it up here in a minute, but I wanted to just see when these all started to fall off as I was putting an AC signal into them. So right now I have a 60 hertz, kind of the same signal you'd get out of your wall socket. Here in the United States, a 60 hertz signal, and I think I have it's about 3.5 volts RMS is what I have it set at. So give me 1 second here. I have no idea how that's showing up on the camera. It looks terrible on the monitor. But W2 AEW. I was watching some of his videos today. These are really good videos, but he does a couple on the oh, what the heck is it? The 260, the Simpson 260. And it's a pretty long video, but he goes in and explains it a lot, and nice little chunks that you can. It's right here. This video right here. If you get a chance to give it a watch it. Especially if you have a 260, and like me, it was probably a million years ago when you actually learned how to use it, and you probably forgot a lot of stuff about it. Alrighty, so basically what I have, this is putting out 3.5 volts set to a 50 ohm load, and I have a little resistor down here. 47 ohm was what I had laying around, and all these leads they're from all the meters going into it. These colors, the yellow and white that you can see, these mean really nothing. The colors mean nothing. That's the leads I grabbed. Of course, when you get up to here, red is the plus and black's the common. I think I followed that all the way through. Okay, so anyhow, if you look at 3.5 volts, these are all set. That's almost 3.5 volts exactly. That's closer to about 3.25, but this really, I don't know if it was ever calibrated for AC. This is the Simpson, and there's 3 and 4. This is almost exactly 3.5 volts. And then I don't know if you can see with the glare. It looks like you can. That's a 3.428 volts, and that's pretty accurate meter. So why this guy back here saying 3.08, I have no idea. Again, like I said, never been calibrated. That's one we'll have to look into. But so what I want to do is just want to see when I start to increase the frequency, who falls off first, who can't really keep up with AC, you may be above the audio frequency. So we're going to jump up pretty quick, maybe run up to 1000 hertz right off the bat, kilohertz, and just see if anybody drops out. So excuse my arm if I'm back here. So I'm just going to say 1. Yeah, didn't mean to do that. So how about we clear that? Go back to 3.5 volts RMS. Make sure everybody's back where they were. Okay. Set the frequency, and we'll just go to 1. Where's kilohertz? Where are you? Right there. He came up. He looks about the same. He came up, didn't he? He's about the exact same. He's about somewhat close. So let's go up. We're going to go. I'm going to just start moving until I see things starting to happen. 2, 3, 4, 5 kilohertz. Okay. So now at 5 kilohertz, he's saying 4 volts. And I'm just making sure that I don't have anything else. It's on AC. So he said about 4 volts. This one here is 3.5 still, 3.5 still, 3.5 still, 3.4 something. I want to just go back to 60 hertz again and see. Am I losing my mind here? Let's just look. I'm just going to type in 60 hertz, 60 hertz. Okay, he dropped down, and so did he, or she. I don't know what they are, but okay, just kind of interesting. So we were what? We'll go back now. We'll go to 6 kilohertz. He's right where he should be. 3.5, 3.5. This one doesn't look like it moved at all. 3.4 moved a little bit. This one, I don't know what the heck that one's doing. All right, let's go. Let's keep our ascent going. 7, 8, 9, 10. The 10, 3.5, 3.5, 3.5, and still whatever it was, 3.42. I think you're out of the game. I don't even know what you're doing. Yeah, kind of interesting. I don't know if it has anything to do with all these crazy connections that I have here. So maybe when we're done, we can just run with just him and see what happens. Okay, that's 10 kilohertz. So let's go. We'll go up to 20, 30. All right. At 30 kilohertz, this one's starting to drop off. This one's still fixed. 3.5, 3.5, 3.5. I mean, these are like perfect. He's at 8.4. All right. Let's see. 30, 40, 50 kilohertz. 60, 70, 80, 90, 100 kilohertz. He's dropped half a volt. He's still fixed right at about 3.5. 3.5, 3.5. Okay. So let's jump up to 200 kilohertz. 200. He's dropping off fast. This might have come down a wee little bit. You still look good. Oh, maybe I moved the lead here. I don't think I did. I don't know what happened to him. Whoop, maybe I did. Here we go. Oh, hang on. His lead popped off. Let me stick it back on here. So I'm sorry, he's at 3. Was he? Let me go back down to 100 again. Has he been at 3 and I've been saying 3.5? Oh wait, I'm sorry, I'm on the wrong. I was on the wrong scale. I want to be on the black scale here. Here's the 5, 3.5. So he's been at 3.5 still. There's 200. There's 300. He's dropped terribly low. Forget about you. The Simpson's down to about 3.25, 3.5, and on the 5-volt scale, 3.5. You're good. So let's see. We'll go to 500 kilohertz. He's down to 3 volts, so the Simpson's starting to fall out. Can't count on you anymore. And again, you were out from the beginning. So really, we're looking at these. So let's go up some more. Let's go to 1 megahertz. He's down below 3 volts. This one can't even figure out what's happening. So I'll put you out of your misery. I'll pull the lead out of you. You're fixed to 3.5 still. You're at 3.5 still. Kind of interesting, isn't it? And now this one does have a probe. I'll tell you that the Ico, and I don't know if you can see it. I'm using the Ico Probe on this one. That's somebody wanting to turn off a different meter over there. That's the Ico Probe. I'll pull this out too, so we don't even have to look at that anymore. But it's not an audio frequency or an RF probe. It's just merely the AC or DC probe. Oops, sorry, just pulled the lead off again. All right, let's shoot up a little bit more. See who falls out next. 3.5. Let's see. 2 megahertz. 3 megahertz. Maybe I'll move my arm off that. What do we got here? Now he's actually started to go up. He's about the same. This one's coming down. Shut up. 4, 5. All right. The way these things function is a little bit different, so that's why I'm not surprised to see them both increasing. Either way, whether it was an increase or decrease, it's no longer inaccurate. So I'm going to go back to get these both. So basically, the digital ones had fallen out first. The VOM fell out. The vacuum tubes kind of kept up. Let's go down. We're at what, 3, 2, 1, 1 megahertz. So let's go backwards. Let's see, can I from there? Yeah, I have 999 kilohertz, so now so it looks like right around 1 megahertz is where these guys will fall off. So again, that's up into the RF range anyhow, so I couldn't see you'd be working up in there without a probe. I was just curious to see. I knew this one would hang on kind of long, and I knew these would hang on a little bit longer, but I didn't know how much. So yeah, definitely you can use these up and through your audio range, most of it, and these clear up practically to the RF range without a probe. But I would think it would probably load down your circuit pretty good, but I can't be sure. Like I said, I'm just using this meter, but I'm sorry, I'm just using that. The RF signal generator, and that's a pretty beefy signal. It's 3.5 volts. So the question is, is even the signal generator starting to fail? Well, I don't know. I know because that, as it gets toward the end of its usable frequency, it'll start to fall off. But 1 megahertz is nowhere near it. I think that goes up to 30. So yeah, 30 megahertz. So that shouldn't be affecting it at all. So it is probably just the meter starting to fall. But it's funny how they'll both fall right around the same time, or just increase right around the same time. Okay, so I think that's all we wanted to do, except I want to take a look at this guy here and see why he was giving me those crazy readings. So I'll just disconnect everything but him or her, well, I don't know what it is, and we'll go and take a look at seeing why. Maybe I'll even leave this DMM with it, and we'll see what the true reading we should be getting is. Interesting. Oh, a couple things I did want to add here. With these meters, this is after I disconnected everything. You can see that they both have kind of fallen out of their zero, so you have to go back in. Now these you should let warm up for probably at least a half an hour. And oh yeah, static is another thing that affects these. Just the static from sometimes when you run your hands across them, they'll go crazy. And what actually works nice is a dryer sheet. Get one of those dryer sheets and wipe the meter face off with a dryer sheet, and it'll take care of a lot of that where it moves with your finger or seems to get stuck. But anyhow, yeah, so these you want to make sure you adjust. This generally only needs set one time usually. You know, if it got beat around a little bit, it'll need it again, but that's not something you always have to adjust, but that's right there. These meters are, you have to set the frequency range that you, sorry, not the voltage range that you want to use. So they're not auto ranging like this guy. I just turn this one on basically and it does the rest. These ones here I have to choose, so I was choosing the 5-volt scale on each one of those, the 10-volt scale on this one. Even that one, it's a digital meter, but if you notice all the buttons, you have to range it. It doesn't auto range. So if I wanted to go up to 20 volts, I push this one. If I wanted to go to 200 volts, I have to push that one. If I want to go down to 2, I push that. Now you could measure 2 volts with that pushed in, but you don't get as accurate as a reading. So you always want to just be the highest that you have to be. And if you're going to start with a voltage you have no idea what it is, and crank this all the way to the far end, and then work your way back. So you just start to get meter deflection. One thing you will notice when I change that, see, so every time you change this, you got to zero the meter out again. This one's a little more sturdy, but this one gets used a lot more. So maybe we'll leave this one on the bench for a while and align it, calibrate it, work the bugs out of it. Yeah, so let me go back to that. I just wanted to show you that these were not auto ranging, and basically what happens when you've had it on for half an hour and you take the power off of it. And they were only warming up for maybe 10 minutes before I started the video, if even that. Alrighty, so now I have just this. The only thing connected to this resistor is, I don't know if you can see it, is the signal generator, of course, in the meter. So just kind of give it a 50 ohm load to keep some noises out of it. So what am I saying? At 990 kilohertz, it's showing 6.6. Let's move it down to the 2-volt range. See, why would you tell me that on the 2-volt range? Okay, on the 20-volt range now, it's closer. 3.7. Well, let's see what happens when I go down to 60 hertz, where we started before. Remember, it was giving me a 3 reading or something. Let's go 60 hertz. Well, there now it's almost It's almost telling me exactly what this guy was. So let me plug. Three, 4, 2, 3, 4, 1. So now it's kind of working what it should do. The only thing I did in between there was kind of mess around with these buttons here a little bit. So now let's see, when I plug all the other meters on, does it have any effect on that? Let me move these guys way in here. Come on, slide in. Got to make room on my resistor for these. I don't know if the meter can pick that up, what I'm doing here. I'm just sliding the leads on the resistor. Okay, 341, 342. All right, let's stick one of the meters back on. All right, so let me put him on the 5-volt scale again. And I guess I should have calibrated it. Remember, I told you whenever you move them around, look, it's way down. I don't know if you can see that meter. All right, put that one, it's staying the same. All right, let's plug somebody else in. This guy would be a plus, and we can put the negative on. I have a negative lead. So now I'm going with the other vacuum tube voltmeter. Okay. What are we showing? Oh, he turned off. Let me turn him back on. 342, 341. So it might have just been dirty switches. I have one more meter to plug in just to confirm everything. If I can just find the leads for it. Oh, here we go. I got the white one will be black. That'll go on that side, and the yellow one will be red, and that'll go on this side. Alright, so everybody seems to be reading somewhat typical now. Let me just shoot it up to 1 kilohertz and see what we get. 1 kilohertz. Good. 341, 3419, 35, 35, 35. Okay. So I must have just maybe didn't have a switch pushed in all the way, or maybe they were dirty and me pushing them back and forth a couple of times. Like I said, that's an old meter. In fact, when I first got it, it didn't even work, and I didn't do anything to it. I just kept pushing the switches, and then it turned on, and then it started working. So probably could use a good cleaning. I got that actually when I bought that power supply, the guy had the meter too, and let me have it for, I don't know, like 10 bucks or something. I couldn't pass it up. And both of these are from ITT, those schools that were out. I don't know if they were nationwide in the United States or not. I know they were out on the East Coast, and it was ITT. It was a technical institute, and I actually went there, but that's where those actually came from. I think all the schools recently went defunct. They're out of business or something, and I don't know how he ended up with them, but he had a bunch of those he was selling. So anyhow, I got it, and yeah, sure, I'd like to have a more high-tech power supply, but that one works just fine for me. And the same thing with the benchtop meter. I like having a benchtop meter, and I'd like to get like a really nice one, but you know, they're really expensive, and I really use the Fluke mainly for when I have to do things that are, how do you want to say, high tech. I've had that since I used to be a mechanic, and then I actually bought that, and I've used that since then. And that's been a great meter. It's pretty durable. It's got the plastic. That's what this rubber shield is. That comes off. That's, I guess, in case you slam it in the hood or something, or drop it on the ground. But it does min-max functions, so you can turn it on and it'll record basically what the minimum and maximum voltages are you saw. So for being just a handheld meter, that does a lot of stuff. And it's pretty accurate. I use the VTVMs more for when I'm working on old-fashioned stuff, because a lot of times that's what they got their voltages from. So when they check and give you the voltages at the tubes or something, you can kind of guess they used one of these. The Simpson, I got it basically for a really good price. I couldn't pass it up, and it was reminiscent of being in high school and in shop class where I first learned to use those, and it just oh, I said, oh, I got to pick one up. And basically what I had before that, where is it? I had the old Radio Shack model, and I don't know, it might have, let's see, I think it's under here. One second. Sorry, little doggy. So that was probably one of my first meters. Trying to zoom in, so zoom out so you can see it. The Micronta, and there's a story with that. I got it, and I was, you know, Mr. Electricity, and I brought it home, and I shoved it in the 110 outlet, like we in the United States in the houses we have 110. And I shoved it in the 110 outlet to measure the voltage, and then I don't know why, but I turned it off. Instead of pulling the leads out, I turned it from AC, I turned it off, or AC volts right here, and I turned it off, and it fried a bunch of diodes in there, so I basically didn't have a meter for a while. And of course, no one else I knew had a meter, and I was, I don't know, I was still in grade school. So I bought one of those little cheapy $10 meters. Not that this was a whole lot more at the time, that was probably like 20. But anyhow, I found some bad diodes in it, and I ordered new diodes and replaced them, and it worked again. So I've had that meter again since probably, oh geez, the 70s. That was my first one. I'm surprised I haven't blown it up more. But all right, that's all I have, and thanks for watching, and hopefully something you can use, or just something to fill a half an hour of your time or whatever. I don't know how many minutes long this was. Probably too long. But again, like I said, thanks for watching. I'll try and get some more videos out if I can. Just been one of those summers where we're trying to get everything done, getting the daughter up to school, getting the grass cut, working on everything, all the lawn tractors and everything, and then we had the darn hurricane come through and give us 8 billion inches of rain. So we made that pretty well. Just had a little bit of flooding in the basement. I'm sure a lot of people did a lot worse than I did, so can't complain. Take care, everyone.